Okay, so supposed to show that first derivative. So I've got x squared plus 2x plus y to the fourth plus 4y equals 5. Differentiating, I'm going to get 2x plus 2 plus 4y cubed dy dx plus 4 dy dx. The derivative of 5 alone will be 0. Moving some things around. These, when subtracted to the other side, become negative. Factor out the dy dx. Divide. We get dy dx equals negative 2x subtract 2, 4y cubed plus 4. Now if the problem had said find dy dx, we could quit, but it said show. So we've got to make our answer look like theirs. So we do a little factoring here. Factor out a negative 2 on the top. Factor out a 2 on the bottom. I guess we could factor out a 4 on the bottom. These will divide. And now we have shown what they asked us to show, because this will become 2. Just verify that I have what they have. And the way points were worded on this is they gave 1 point for getting to here. They gave a second point for getting to the end. So 2 points possible. Write an equation for the line tangent to this curve. So this is our equation for finding points on a curve. We already have the points, we just need the slope. This is the equation for finding the slopes on that curve. So our point is at negative 2, 1. We need the slope right there. That slope is the same thing as dy dx at negative 2, 1. So go find that. Make sure you use parentheses when replacing the x. And parentheses when replacing the y. No numeric simplification is required. So I'm actually going to leave that. So now my line tangent equation is that big thing just have to be really careful you don't mess up a parenthesis. Or it's really pretty easy to simplify. You can just simplify it. Don't mix up the x and the y. And if I get that far, they'll give me a point. Find the coordinates of the 2 points. Read slow. 2 points on the curve. Here's the curve. Looking for 2 points where the line tangent to the curve is vertical. Okay, here's my formula for finding the slope of a line tangent on the curve. For that slope for that line tangent to be vertical, this equation for slope would have to have a denominator that is equal to 0. The only way for the denominator to be 0 is if that's equal to 0. Therefore, taking the cube root of both sides, you're going to get that y has to equal -1. So there are 2 points whose y-coordinate is -1. Those are the 2 points where the line tangent will be vertical. If you get this far, they'll give you a point. Now we just need to use the equation of the curve when y is equal to 1 to find the corresponding x-coordinates. So we have x squared plus 2x plus the y value is -1 to the 4th -1 to the 4th power will be +1. This is a quadratic, so to solve the quadratic, I'm going to group all terms on the left. So I'm going to move the 5. It will become negative. And now I'm going to factor. Oops. And I multiply it out one more time just to make sure it's working. So I've got x times x is x squared. X times 4 is 4x. Plus -2x would be +2x. And then -2 times +4 is -8. So it did factor correctly. So the x-coordinates are 2 and -4. The question asked me to find both points. So at x equal 2, comma, y equal -1. And x equal -4, y equal -1. The curve has vertical tangents. And that's the second point. So finding the 2 points. I don't really think you need the words on this one. As long as you somehow indicate that you found both points, that will give you a second point for that problem. Okay, G is continuous. G of 2 equals 5. Graph of G prime is shown. -3 to 7. Yep, that's consistent. So we're good. Find the x-coordinate of all point of inflection on G. So G has a point of inflection when G does this. And we're looking for when G prime does this. Here and here. So we write at x equal 1, G prime changes, increase to decrease, at x equal 4, G prime changes, decrease to increase. So G, not G prime, has inflection points at x equal 1 and x equal 4. On the original AP test, they gave 2 points for that. For this slightly more challenging retake practice, we'll give you 1 if you have all of that. So you have to have the points. You also have to have the correct explanation to get the point. Find the absolute max of g on the interval. We did this on question 1 today already. So we've got to eliminate candidates. You know the absolute max is going to occur at a critical or end point of g. So right here, step 3 and 4, we write down in our paper g prime of x is equal to -1, 0 at x equal -1, x equal 2, and x equal 6. So we have 3 interior candidates and we have 2 endpoint candidates. Therefore, we're going to have to eliminate 4 of the 5 candidates somehow. So copy this over. Clear this off. G of 2 equals 5. Okay, looking for the absolute max. So I can eliminate that one with some words. At x equal -1, g prime changes negative to positive. So g has relative min at x equal -1. So we've eliminated that candidate. Oh, same thing was happening over here at x equals 6. So we can just add that at x equal 1 and x equals 6. And that will eliminate those 2 candidates. So we have 3 candidates remaining. 1, 2, 3. And so we're going to have to use integrals. There's no way to use words to eliminate these candidates. So we use the fundamental theorem. And we write the integral from x equal -3 to x equal 2 of g prime must equal g of 2, subtract g of -3. Solving for this, so g of -3 is going to equal, g of 2 is 5, big parenthesis for this subtraction there. Okay, from x equal -3 till x equal 1, these values of g prime are negative, so all of this area will count negatively. It's 2, 1, 2, 3, 4. So this is 2 times 4 divided by 2, or just 4. But it counts negatively. Then, from x equal -1 until x equals +2, all the values of g prime are positive. 2 times 1 divided by 2, that's just 1. 1 times 1 divided by 2 is a half. So g of negative 3 distributing here, distributing the negative, this will become plus 4 minus a half. So that's going to equal 9 minus a half, or 8.5. So currently that seems to be the largest value of g. Now we go find the other one. So g, it's going to do the fundamental theorem again. So the integral now from 2 to 7 of g prime is to equal g of 7, subtract g of 2. So then g of 7 must equal g of 2 plus the integral. So g of 7 is going to equal g of 2 is 5 plus the integral, so g prime. From here, g prime is all negative. This is 2 times 2, and 2 times 2. 2 times 2 is 4, half of that is 2, so that's going to be negative 4. For this little section, g prime is positive, so that's 1 times 1 is 1/2. It's a triangle. 1 times 1 is 1, half of that is 1/2. So this is going to be 1 1/2. Now I just need to write down the answer. So I got going a little fast over here. I forgot about this 1. 1 plus a half is 1 1/2, or 3/2. Which means this is 9 subtract 1 1/2, which is really 7.5. That's the largest value. I just have to write down the answer now. The absolute max of f, not f, g, sorry, of g is g of negative 3, which has a value of 7.5. They gave points on this one. So way back here, this was 1 point. If they saw me checking, looking, so they looked to see if I find g of negative 3 and g of 7. Even if I made a mistake trying to find them, they'd give me a point for trying to find them. Like I recognize I need to find these two values, they give me a point for that. And then the third point is for the correct conclusion. So 3 points total for that part. Find the average rate of change of g. Here we go. Average rate of change of g. So the average rate of change of g is going to equal, on the interval negative 3 to 7, that's going to be g of 7, subtract g of negative 3. I'm just following this formula. All divided by 7 minus negative 3. Don't go fast. Back here we found g of 7 to be 1.5. we found g of negative 3 to be 7.5. So minus, here's the minus right here, minus, that's that minus. G of negative 3 is, one more time, 7.5. Now I don't need to do any other simplification. And they'll give me a point for that. Find the average rate of change of g prime on the interval. So now we're doing average rate of change of g prime. Means we've got to go find g prime of 7, subtract g prime of negative 3. That's actually easier because they gave me a graph of g prime. So I write g prime of 7, subtract g prime of negative 3, divided by 7 minus negative 3. You have to go one more step here. G prime of 7 is 1. G prime of negative 3 is negative 4. So again, here's the negative, then the subtraction. Now I've got to go g prime of negative 3, which is negative 4. I don't need to do anything else. So if I get that far, they'll give me 1 point. Keep reading. Does the mean value theorem. So I grab my notes. And let's clear this off here. Does the mean value theorem. So the mean value theorem says that the average rate of change of something is going to equal the instantaneous rate of change. Does the mean value theorem applied on the interval guarantee that there's some x coordinate called c where g double prime of c is equal to this average rate of change? See, the mean value theorem, this is on your original golden notes, would say in this particular case that g prime of 7 subtract g prime of negative 3, all divided by 7 minus negative 3, that has to equal somewhere g double prime of some c. And they're asking if that's true. Is there going to be some g double prime of c that will equal this? Why or why not? Well, looking at the picture, here's the problem. G prime is not differentiable because of the corners on G prime. Therefore, that's what you write. So you say no, since G prime is not differentiable at x equal negative 1, no, yeah, x equal negative 1. That's a corner right there. X equal 1. And x equal 4. Therefore, the MVT does not apply. And now I'm just going to copy their words. So, for negative 3 to 7, there is no C for which G double prime of C equals, I have to go back and look here. Oops, not there. We crossed it out because we needed the space. So we had up here G prime of 7 minus G prime of negative 3 is equal to over 7 minus negative 3. This turned out to be 1 minus negative 4 all over 10, which is 5 over 10. It's 1/2. So this would be 1/2. If you have the pink, they'll give you the second point for your explanation.